All right, so crazy enough, we are in week 6 of this nonsense. This is what we're going to cover this week. So we're going to do 10-4 today, and then we're going to do 10-6 on Wednesday. So your homework for 10-4 will do Wednesday. I'll go over the warm-up on Wednesday, and then we'll do 10-6. 10-6 is kind of long, so we'll probably divide it into 2 parts. You'll get like part 1 on Wednesday with an assignment due Friday, and then part 2 on Friday. We'll finish it up. That's like a lot of circles stuff. So today we're going to talk about perimeters and areas of similar figures. And then the next section is circles. Juliana, I'm assuming you guys are coming in from a second device. Juliana, Kylie. Feel free to do that, guys. If you want to take notes, we're going to do notes together. So if you always want to join from a second device, that's totally your option. And then that way you can kind of like watch it instead of having to flip back and forth on the same device, because I think that's a little bit harder. Okay, so let's talk about the good news is this. So again, scale factor one to the other. You set up the ratio, you simplify it to the scale factor of this initial rectangle, and then this one, if we said smaller to larger, would be 1 to 2. Because it'd be 2 over 4, which reduces to 1 over 2, 5 over 10, which reduces to 1 over 2. So 1/2 or 1 to 2 would be the scale factor. And the ratio of their perimeters is the same as the scale factor. So it would also be 1 to 2. And the ratio of the areas, you square both parts of your ratio. So I would square 1, square 2, and I'd get 1 to 4. Sure. So that's pretty much all you need for the whole section. The rest is just application of it. So example 1 says the trapezoids given are similar. Find the ratio of the perimeters and then find the ratio of the areas. So for the perimeters, you want to find and we're going to go small to larger again. I'll look back at the homework. I think it says which ones to do. Sometimes it'll say left to right. Sometimes it'll say small to large, bottom top, whatever it is. Just pay attention to those directions. So this one says find the ratio of the perimeters. So if the scale factor of these trapezoids is 6 to 9, because those are the sides that match, then you want to see, is that simplified? So can I simplify 6 to 9? Yeah, right? 3 goes into both of those, and it would be 2 to 3. So this is the scale factor. 2 to 3 is the scale factor of that smaller trapezoid to the larger trapezoid, which means the ratio of the perimeters is going to be the same, 2 to 3, or 2 to 3 like that. And the ratio of the areas would be 2 squared to 3 squared, or 4 to 9. Easy stuff, right? Just set up your scale factor, reduce it, and that's the same for the perimeters, and then you'd square it for the areas. All right, example 2 says 2 similar figures have corresponding sides in the ratio of 5 to 7. What's the ratio of the perimeters and what's the ratio of the areas? So if my scale factor, or the corresponding sides are 5 to 7, what's the ratio of the perimeters? Anyone want to unmute and answer, or raise your hand so you can give us the answer, or even type it in the chat if you don't want to hear your own voice? That's fine. Good. It's 5 to 7. Same as the ratio of the sides and the scale factor. How about the areas? Perfect. 25 to 49, or 25 over 49. And this would also be 5 to 7. So either of those answers work. Good so far? David, you've fallen asleep. Correct. Yep. All right, anybody still copying that down? You can't. So you can't reduce by square rooting, and that's probably the most common mistake made here. No number goes into both 25 and 49. I know your brains look at it and say, well, but I could square root both parts. But you can't square root. That's not how we simplify. You have to divide into it. Yeah, it's probably the most common mistake people make, Lisa. So just be really careful. Unless you can simplify by dividing in the same number, you can't simplify. And most of the, well, not most of the time, all of the time, if your scale factor or your ratio of your perimeters is already simplified, you'll never be able to simplify your area. So as long as you start with a simplified ratio, it will stay simplified when you square it. Okay, example 3 says the area of the smaller polygon is about 27.5 square centimeters. What's the area of the larger regular polygon? This is where it gets a little trickier, and this is where standardized test loves questions like these, okay? So the first thing you should notice is that you have 2 polygons, and all you have is the side lengths of them. So if I wanted to set up the scale factor, if I wanted to set up the ratio of the side lengths, it doesn't matter what order I pick, but let's say I'm going to follow smaller to larger. Then I want to put the smaller in the top, and I want to put the larger in the bottom. So the ratio of sides would be 4 to 10, which reduces to 2 to 5. So this is my scale factor. The ratio of the sides, and the ratio of the perimeters. That same answer is the answer for all 3 of those parts. But we're not talking about perimeters. This is giving you an area, which means I have to do what to those numbers? Square them, right? So the ratio of the areas would be 2 squared to 5 squared, or 4 to 5. This is the ratio of the areas. Now I have to set up a proportion and cross multiply and divide. What they give me is the area of the smaller polygon. So that's going to go in the top because we went smaller to larger. The area of the smaller one goes in the top. The area of the larger one's what we're missing. So that's where my variable is going to go. So I'm going to, it should be, 4 to 25. 4 to 25, because it's 2 squared to 5 squared. Now, on a question like this, I would let my calculator do the work. I'm going to cross multiply. I'm going to multiply 4 times x equals 27.5 times 25. And I'm going to do 27.5 times 25. 4x equals 687.5. And then I'm going to divide both sides by 4. And 687.5 divided by 4 is 171.875. And it will usually tell you what to round to. Let's say it said nearest tenth. That's 1 decimal place. So the area of the larger polygon, which is what we were looking for, would be 171.9 centimeters squared, because it's area. So if it had given me perimeters and it asked for the perimeter of the new shape, then I would keep the 2/5. I would do the smaller to larger, which is 2 to 5, equals the smaller to larger, whichever one I have, whichever one I'm missing. Because it said area, we had to square the 2/5 to get 4/25. And then let's say it gave me the area of the larger polygon, then the number would go in the bottom and the small one would get the X. But once you set up that proportion, you're always going to cross multiply and divide. Questions on that one? Anybody still copying it down? Okay. Last example is example 4. It says the scale factor of two similar parallelograms, that should say grams, is 3 to 4. The area of the larger parallelogram is 96 square inches. What's the area of the smaller regular parallelogram? So here's my scale factor, 3 to 4. Which means the ratio of the areas would be what? Good. Close. 9/16. Good. So now I've got the area of the smaller one's going to go in the top. So this is going to be smaller area over larger area. You're going to know one of those. And we have to go back to what we were given to see that. This says larger parallelograms 96. So I'm going to say 9/16 equals smaller is X, larger is 96. And then just cross multiply and divide. So 9 times 96 equals X times 16. 9 times 96 is 864. And then divide both sides by 16. And I get 54. And the units is square inches, so this would be 54 inches squared. Questions on that one? So again, scale factor, side length, perimeter, all the same. And then the ratio of the areas you square, both the top and the bottom. All right, if you'll go to Canvas and grab the homework for tonight, the 10-4 homework. Alright, so this is what you're going to work on. We've got about like 25 minutes. You can probably get this finished. So the first section says the figures of each pair are similar. Compare the first figure to the second, and then give the ratio of the perimeters and the ratio of the areas. So you should have 2 answers for each of those questions. Ratio of perimeters and then ratio of areas. And then for 13, 14, 15, and 16, these are like the ones we just covered. It says find the figure of each pair are similar. The area of one is given. Find the area of the other figure. And this time it says to the nearest whole number. So you're going to round it to the nearest whole number. And again, you can use your calculator on those. Just set them up, cross multiply, and divide. So that's what I want you to work on now. Again, get it open and get working on it. And then if you've got questions, please feel free to ask. This is your opportunity to kind of get your homework done before we even finish class. So then I set it up as 1 to 4 equals 6 to x, and then cross multiply, and there's no dividing this time because it's just 1x. And I get x is 24.